So what we were talking about yesterday, I've got a prism. What kind of prism are we looking at?
Rectangular.
Okay, you can see there's two prisms, a triangular tacked on top of a rectangular. You also see it's just one kind of prism.
Hexagon.
Why pentagonal?
Because 5 sides.
I count 4.
There's 4 sides.
I count one side along this. I count this side here, which is 6. No, the whole thing is 6. Because I've got 3 for just this piece, and then I've got 3 for here, and then I've got 1 along the base. Now those are implied right angles. I have one side here, and I got one side there. So we call that a trapezoid. So it's actually a trapezoidal prism kind of set on its side. So in the context of what we talked about before, I can see this as a whole bunch of cards that are cut like trapezoids, all kind of lined up together and smushed into one stack. So when I go to approach finding the surface area of it, kind of the format we've been following is that I know that for any prism, there are 2 bases and the wraparound or the lateral area. Now, one thing to bear in mind with this, if you want to look at it from the standpoint of break it into pieces and add up the area of each of those pieces, you could say, well, I've got a rectangle here, a triangle here, some rectangle there. I've got rectangles here, 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 and down here in the bottom. And just find all those areas and add them all up and it'll work. Again, the problem with that strategy is that you're going to find yourself fighting against the more complex these get, the more steps that get involved, and the easier it is to lose stuff. So I think of this base as this front piece. So that front base is a trapezoid. So that means it's going to be half the sum of the 2 bases times its height. So half, let's see, 3 plus 6 times 4. So it's 3 from that far side, it's 6 is this long side here next to me, and it's 4 along that bottom piece. And that's a trapezoid, so that's the area we practiced last chapter.
Wait, 6 total?
Yeah. This whole piece right, where's my pen? There it is. This whole piece right here is 6. Because it's 3 up here, and then it's also 3 down here. So that means my base is going to be, let's see, that's 9 times 4 divided by 2 puts me at 18 square centimeters.
Yeah, now I have to copy out at work, so I'm still
Okay. I'll give you guys a second to get caught up then. And again, it's going to take a bit to get used to sketching these as we go along. I'll even admit to cheating by grabbing some graphics and stuff from the online book and dropping them in.
Does anyone have any lotion? Yeah, no,
Now I still got to do that wraparound, right? So what I'm going to do is I'm going to mark off a rectangle that is that wraparound lateral area in order to get a better idea of what it is I'm looking at. Now the wraparound, that's the one that goes around this way, is 2 centimeters tall. Not 2 meters. Two centimeters. So let's see, if I go through the sides, here's a piece that's going to be 4 long, 3 long. So that takes me, I've done this piece, 4, and then I've gone 2, or 3 I mean. Now I got to do this one.
Shouldn't the one on the left, the height be 3? Not 2? Because 2 is the bottom, so she go 4, 2, 4, 2, and then 3 on the side.
Okay, that would be,
Right?
Sort of. You've got kind of the right idea with the idea of wrapping around, but when we talk about 2, this 2 right here,
Yeah.
okay, the piece I'm cutting is the piece that's this piece, and then along the bottom, and then along this side up here. That's the piece I'm cutting out.
Oh, we're not doing this.
Right, I'm doing the wraparound this way, not this way.
Okay.
So again, just falling back to the old classic piece of paper. Another nice thing I like about this chapter is if you get stuck, you can always just take out some stuff and play with it, and you'll kind of get an idea of what you're looking at. I've got a big piece here, like that, and then I've got this piece. No, it's too big. So it kind of looks like that. Forget that. You know what I'm talking about, though, right?
No. Yeah.
2 here, along this side right here, and then up to here. So that rectangle, 2 by 3, is this one right here.
Okay.
And then I'm going to keep going around the figure this way. So this is going to be, so it's 4, 3. I'm not sure about this slant yet, and then 6 coming down the far side. Now there's that one slant piece, which I'm going to have to find the area of at some point anyways, right? So if I look at this triangle, this triangle right here, well, that's a 3 by 3, 4, 5, isn't it? Or rather, let's just pull that triangle out. It's 3 on this side, it's 4 on this side. Pythagorean theorem tells me if I do the work, 3 squared plus 4 squared is c squared. I've got 5 along that side. So this length must be 5. 3 squared is 9, 4 squared is 16. So 25 is equal to c squared, so c must be 5. The hard part about working with non-rectangular prisms or non-cylinders is there is a lot of work in these other measurements. The advantage is if you can break it down to pieces you recognize, the trapezoid front, the trapezoid back, and this one long rectangle where I have to do a little bit of Pythagorean theorem, it makes it a little easier. It's still not the fastest, but it's not as bad as it could be. So now I look at this whole rectangle. Looks like this whole length, let's see, 7 and 11 puts me at 18. So the lateral area must be 36 square centimeters. That's the area going around the prism. So its total surface area is twice the base, which is 18, plus the wraparound, or 72 square centimeters.